Okay, here's a couple quick examples with a sphere using the formulas that we have. Good videos that show how we derive the formulas are posted in Schoology. So I'm going to go ahead and skip that, and I'm just going to use the formulas and show you how to plug stuff in. So, basic example, this is number 40 on your worksheet if you want to follow along. Radius of a sphere is radical 2 centimeters, and we need to find the surface area and the volume. So formulas are there. All we're going to do is we are going to plug in. So using my formula, 4 times pi times, we said the radius is radical 2. So there's my radius, and of course I have to square it per the formula. So first thing I'm going to do is actually square that. Radical 2 squared, the radical and the square cancel each other out. So we get a 2. So we have 4 times pi times just good old 2. And we can, of course, multiply the 4 and the 2 to get 8 pi centimeters squared for my exact answer for the surface area. Notice that there's just one surface area. We don't have a lateral area when we talk about a sphere. And a base area, we just have that curved surface that goes around it. Looking at the volume. So we've got this lovely fraction, 4/3 times pi times this time we have radius cubed, which means I've got a radical 2 cubed. So just a little aside for how do I do radical 2 cubed? Well, remember when we have something cubed, that means we're multiplying by itself 3 times. So that means I really have radical 2 times radical 2 times radical 2. And radical 2 times radical 2 is going to give me a 2. I've got one more radical left over. So 2 radical 2 is actually going to be my answer for radical 2 cubed. So looking at that, I've got 4/3 pi times 2 radical 2, and I'm going to consider that over 1, the pi over 1. I've got one fraction now. Multiplying across the top, 4 times 2 is 8. Radical 2 pi all over 3 times 1 times 1 on the bottom, which is just 3. So 8 radical 2 pi over 3 units cubed is my volume in exact form. Okay, I did a hard one with you. Some of them aren't going to give you a radical in there, but I wanted you to see how you actually cube a radical. Let's one more example, extending the concept a little bit in 2 ways this time, because this time I'm giving you something besides the radius or the diameter. I'm giving you the volume. You're going to have to work backwards, and it's also a hemisphere, not a sphere. Hemisphere is simply just half a sphere. So I'm on number 43 on your worksheet, if you want to follow along. And we're told the volume of a hemisphere is 1,152 pi cubic centimeters. So I'm going to go ahead and put that in, that my volume is 1,152 cubic centimeters. And I don't know if I said the pi with it. It's 1,152 pi cubic centimeters is my volume. And I got to figure out what I'm going to set that equal to. So for my formula, I've got 2 options actually. I could take my volume formula for a sphere, which is 4/3 pi r cubed, and I could take 1/2 of the 4/3 pi r cubed. And if we take 1/2 of 4/3, we're multiplying fractions here, we're going to end up with 4/6, which reduces to 2/3. And maybe you just did that in your head. So I'm going to go ahead and say that my volume of my hemisphere is 2/3 instead of 4/3. 2/3 pi r cubed. There's some variations to that. So if you were thinking 4/3 pi r cubed all over 2, that just tends to look a little bit more complicated. So I'm going to go with 2/3 pi r cubed. And now I'm down to looking at this. Okay, other option, you could have doubled 1,152 pi, and I don't have a calculator in front of me right now, but you could have set twice that equal to 4/3 pi r cubed. So essentially you're taking the volume of the hemisphere, multiplying by 2 to get the volume of the whole sphere, and then using your formula that we have from our other problem for the entire volume of the sphere. Okay, that would work just as well. Okay, I'm going to go ahead and solve this one. Let's see what we get. First thing I'm going to do is divide by pi on both sides and get those to cancel out. I'm going to be left with 1,152 equals 2/3 r cubed. And to get rid of a 2/3, we could do it in 2 steps, multiply by 3 on both sides, and then divide by 2 on both sides. I'm going to take a little bit of a shortcut, and I'm going to say let's multiply by the reciprocal of the fractions. The 3 cancels, the 3's cancel, and the 2's cancel at the same time, and I'll be left with radius cubed is equal to, I don't like that 3, let's fix that. Radius cubed is equal to 1,152 times 3 divided by 2, or times 3 halves, which is coming out to 1,728. And at this point, I'm taking the cube root of both sides. I'm uncubing it. So cube root, if you don't remember how to do it in your calculator, find the math button. That would be the 3rd button down on the very left-hand row, or left-hand column, I should say, of keys, right underneath the 2nd function button. Math, and then it should be the 4th option there, cube root. There should be a little 3 in front of the square root symbol. When you type that in and then into the number 1,728, you should be getting 12 for your answer. So I know the radius is 12. Okay, do make sure you know how to do that in your calculator. Actual question was, find the surface area, total surface area of the hemisphere. So I did that as an intermediary step because I knew I need my radius in my surface area formula. So I now know my radius is 12. Let's go to our surface area formula. So recall that the surface area of a sphere was 4 pi r squared. So hopefully you can reason that we could take the 4 pi r squared, divide it by 2, and you're probably thinking right now that our formula is going to be 2 pi r squared instead of 4 pi r squared for the surface area. Now I'd ask you to think closely about the surfaces, and I say plural, that we have on our hemisphere. Picture the whole sphere. You cut it in half. You still have half of the curved surface. And that's what this is right here. That's half of the curved surface. But my hemisphere is actually sitting on a base. We created a base when we cut it off. So we actually have one more circle that's now part of my surface area. And to have the surface area formula correct, I'm actually going to have to add that base. Again, that's the base that we're looking at, pi r squared. So simplified formula for surface area of a sphere would actually be 3 pi r squared, because we have 2 pi r squared plus another 1 pi r squared. And again, this part right here is my surface and all the way around it. This part right here is actually the area of my base that I'm now looking at. So using my formula, my 3 pi r squared, let's go ahead and plug in our radius, which we got a 12. And at this point, it's just a calculation. I'll take you through it, but you're fine with this, I'm sure. No tricks. 3 times pi times radius squared. Remember, squared in surface area, cubed when we get to volume. So 3 times pi times 12 squared is 144. And 144 times 3, I'm getting 432 pi units in this problem were centimeters when I look back. So centimeters squared, since I'm talking surface area. That would be your final answer. Again, that was problem 43. Use this formula that we just came up with when you get to the next problem. I believe you're going to need a surface area formula for a hemisphere. So we now derived really the volume and surface area formulas for the hemisphere. Hope that helps. Good luck working through the rest of those problems.